Welcome to Foundation of Quality and Lean Six Sigma and Introduction to Quality Management course. In this video, we will review the definition of quality, the cost of good quality, and the cost of bad quality. We will also look at quality models, the traditional cost of quality and emerging cost of quality. Let's start by defining the quality. So what is quality? There are many definitions of quality. However, in the scope of Lean Six Sigma, quality is conformance to the customer requirements or customer expectations. Quality is fitness for use. Quality is predictability. Quality has two perspectives. From customer point of view, quality is fitness for purpose, compliance with the requirements, adds value at the best cost. From the supplier point of view, it's a little bit different. The supplier thinks of quality as reducing cost of quality, increasing market share, and maximizing return on investment. Cost of quality. Let's start by talking about cost of poor quality. And why should we think about quality at all? And why should we learn about quality management? Well, from the practical point of view, quality comes at a cost. And the cost of bad quality is the total cost of labor to fix defects plus the cost of materials for rework. There is a 1, 10, and 100 rule, and it says that the prevention cost is less than cost of redesign and the design review, and redesign cost is less than cost of inspection, and the cost of inspection is less than the cost of repairs if a defective product reaches the customer. So the total cost of bad quality is cost of labor plus cost of materials plus scrap plus cost of undiscovered and remaining defects. Iceberg of cost. To better illustrate the cost of bad quality, let's look at the iceberg of cost. Costs such as scrap, rework, warranty cost is usually easy to observe and capture. However, hidden cost of poor quality is harder to estimate. And costs are additional engineering and management time, production downtime, increased inventory, decreased productivity, late delivery fees, and loss of orders. Cost of quality and quality management system. We just learned about the cost of bad quality. But how about cost of good quality? So let's discuss cost of quality and quality management system. The advantage of quality management system is that the cost of good quality is controllable and it can be managed through preventive action and appraisals. So what is included in the cost of good quality? There are costs associated with using APQP, Advanced Product Quality Planning, FMEA, Failure Modes and Effects Analysis, FTA, Fault Tree Analysis, Control Plan, Process Capability Analysis, Variation Reduction, Lessons Learned, and Continuous Training. In addition, the appraisal has a cost of inspection costs, in-process inspection, final inspection, calibration, auditing, approvals, and factory acceptance tests. There are two types of failures: internal and external failures. We consider the failure internal if it happens before the product or service leaves the shipping dock or deployed. External failure is the type of failure when the product or service reaches the customer and the customer discovers the defects. Cost of poor quality due to internal failure will add up in cost of process delays, rework, scrap, retest, validation, corrective and preventive actions, downtime, and loss of capacity. External failures will add cost of customer returns, warranty, loss of customers and sales, and repairs at the customer location. Total cost of quality. We just reviewed the cost of good and bad quality. Now, how to add it up? Total cost of quality increases over time. At the beginning of the life cycle, there's prevention cost, then failures found during testing and design, failures during manufacturing, defects and problems discovered during inspection, installation, field repairs, failure found by the customers, and the liability costs. To model all the costs, we use the cost of quality model. There are two well-known cost of quality models. Traditional cost of quality model. The graph depicts the cost of appraisal and prevention grows exponentially with the increase of quality conformance. However, the cost of failure exponentially goes down. By adding both curves together, we get parabolic total cost of quality. Another model is called emerging quality model. The emerging cost of quality model, on the other hand, tells us that the cost of prevention and appraisal goes up almost linearly. Cost of failure drops exponentially. And the sum of two curves is exponential reduction of total cost of quality. Now let's look at the examples of good and bad quality costs. Prevention cost examples are research and development, marketing research, progress design meetings and design reviews, factory tests, field tests, and final acceptance tests, and operator education. Costs of appraisal and inspection, and cost of measurements, planning inspections, test audits, process control, field performance evaluation, review of tests and inspection results. Examples of bad quality costs: internal failure cost and design changes, rework, scrap, purchasing replacement materials, troubleshooting and reinspection and retesting. External failure costs are failure investigations, returned goods, repairs, recalls and warranty, potential penalties for late delivery, and loss of sales.